Hi everyone, I'm Hannah. I'm a tutor with Sky Academy, and in this video we're looking at statistical analysis, and in this topic there's two subtopics. We have MS4 and MS5, and specifically in this video we're looking at MS4 or bivariate data analysis. So just quickly before we start, bivariate data is data that will have two variables. And we have to determine whether there's a relationship between these two variables. So if we have a look at the next slide, this example in the table of values, we have two variables, one being arm span and our second one being height. And so a relationship between the two might look like the longer you have your arm span, the longer you are height-wise, the taller you are height-wise, or vice versa. The shorter your arm span, the shorter you are height-wise. So let's have a look at how to construct a scatter plot. So firstly, what we would do is we would draw a number plane. So I'm just going to do that. We're going to do our y-axis as our vertical axis and our x-axis as our horizontal axis. And if you're like me, I like to write on which one's which so I don't forget. And we know that the one on top is always x and the one on the bottom is always y. So once we've drawn the number plane with x and y, we can go and determine a scale and a title for the horizontal axis and do the same for the y-axis. So I'm going to do those two steps together. So I'm going to quickly write on my title for the y-axis, which I know to be height because they give it to us, and for x-axis it's going to be arm span. Now I can go ahead and determine a scale. So a scale is something that you go up by. So if I'm doing for our x-axis, I'm going to do a scale of 5. So I'm going to go up by 5 intervals, intervals with a value of 5, if that makes sense, because the values I've been given all can be divisible by 5 without leaving any decimals or any messiness on our graph. And the same for our height. I'm going to go up with a scale of 2. So there's two ways, I think there's two ways to determine a scale. You can just have a look and see what number is divisible by all the values you've been given, or you can just have a look and see what number would evenly space out the values you've been given. So for example, if I had like 200, 360 or something, you could go up by 50s, like 50, and then you'd have the 60 point, and you'd go up, so on. And same with our height. So a number that can go into all of those is 2, or a number that I can go up by is 2, 2, 4, 6. So I'm going to go ahead and write that onto my y-axis. So we have 2, we have 4, and we have 6. And if you're doing this on paper, it would be a good idea to evenly space these out. So if you had a ruler, you could measure like 2 centimeters or 1 centimeter in between each interval. I'm just doing this on my computer, so I can't measure it. So I'm just judging by eye. So maybe 5, 10, and 15. All right, so now we've got our scale, we've got our height, our scale for our arm span and our scale for our height. We can go ahead and plot each ordered pair of numbers with a dot. So our ordered pairs are what is above and what is below. They correlate with each other, they're associated to each other. So our first ordered pair is going 5 across, 5 along the x-axis and up to 2. So there, then 10 across and 4 up. and 15 across and 6 up. So that would be a simple scatter plot. It only has 3 values, so very simple. Some table values might have like 15, for example, but this one was very simple. So I'm just going to quickly demonstrate. If I had values of 7.5 and 12.5 and values of 3 and 5 in here, I can actually plot these points in red onto the scatter plot below, but it would just change my scale. So let's have a look. If I was to plot 7.5, well, 7.5 is halfway between 5 and 10. So I would draw it about halfway between 5 and 10. And the same, 12.5 is halfway between 10 and 15. So I'd point it there. And 3 is halfway between 2 and 4. And 5 is halfway between 5 and 6. Now, to determine what my scale is now, I can just see what we go up by. So here we're going up by, like say I had a 1 here, we're going up by 1s. We're going up from 1 to 2, 2 to 3, 3 to 4. So that's with intervals with a value of 1. So my new scale for height would be 1. And if I do the same on the x-axis, what I'm going up by from each one is a value of 2.5. And another way to determine this is just to minus the intervals from each other. So if I had 15 minus 12.5, 12.5 minus 10, and if I did that for all of them, you would get a value of 2.5. And if I did that for my y-axis as well, 6 minus 5, 5 minus 4, and if I did that for all of them, I would get a value of 1 for all of them. So that's another way to determine what the scale is. And then you can simply plot the points. So 7.5 to 3 and 12.5 to 5. So there we have a new scale going up by 2.5 on the x and going up by 1 on the y with our points in there. So just to recap how you would do constructing a scatter plot, you would draw your number plane with your y and your x-axis. Then you would look at your table of values, determine a scale or what number you want to go up by, put that scale onto your x and y axis, then look at your ordered points and plot them, plot each pair onto your number plane, and then you would label them height, arm span, x, y, blah, blah, blah. So that's how you construct a bivariate scatter plot. Now let's have a look at the next slide. We are rating a scatter plot this time rather than constructing one. So they've given us a scatter point. I'm just going to label them quickly because I like to label them. On our x-axis or our horizontal axis, we have internet use. And as our y-axis or our vertical one, we have numeracy score. Just a bit of context into this scatter plot here. If there's a relationship between the two, we could think before we even start answering any questions. So internet use and numeracy score. And if you read the question, which we haven't done yet, but if you had, each dot is representing a country. So if we are looking between a relationship between internet score and internet use and numeracy score for countries, a country that might have, like Australia, lots of internet use, kids might have access to lots of resources on the internet, lots of YouTube videos, lots of mathematic booklets on numeracy, so on fractions, on long division, for example. But a country that have no internet use won't have access to all of these resources that are available on the internet. So countries without internet use, their numeracy score might be lower and countries with internet use might have a higher numeracy score just because they have more access to resources on the internet. So that's a bit of background, a bit of context. So you can determine if there will be a relationship or not before you even do the example. But yeah, let's just have a look at question A. Well, first, let's read the question. The average numeracy score for Year 6 students and the general rate of internet use in percent for 10 countries are displayed in the scatter plot. So question A, what is the scale for the vertical axis? So if you remember, our scale is just what we're going up by. So if we have a look here, it might be easy just to say that our scale is 50 because we're going up by 50 from 50 to 100, 150, 150 to 200. But if you have a look, there's actually other little dots here, other intervals that just don't have a value labeled to them. But they are still going up. So we have to determine what the smallest scale is. So if you have a look, there's 1, 2, 3, 4, and then 5. So there's 5 lines there. So if we divide 50 by 5 on your calculator, you would get, I don't know if you can see that, a value of 10. And so we can then assume that the scale is going up by 10. Now we can test that out. We can actually have a look. So if we went up by 10, 20, 30, 40, then we should hit 50. Yep. 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, and so on. So you can actually, pardon me, we can actually test that our scale is correct. Question B, what is the average numeracy score for the country which has internet use rate of 24%? So once again, you'd go across and you'd have a look. Well, 20 is here, but we need to have a look at what our scale is. So if we have a look from 10, we have 1, 2, 3, 4, 5. So we also have a value of 5. So if we divide 10 by 5, we get 2. So the scale for the x-axis is 2 and scale for y equals 10. So if our scale is 2, that means at each dot we have an interval of 2. So if we have 20 here, we have 22 at the next dot and then 24 at the dot after that. So 24 must be there because we have a scale of 2. So if you've got 2 lines, that's 2 times 2, which is 4. So 24, that's what we want. And when you're doing questions like this, to determine the numeracy score, which is on the y-axis, the easiest way to do it would be to use a dotted line. So you use a dotted line and you go up until you hit a point. And once you hit a point, you then go across. And when you go across, you will reach a value. And then you have a look and you go, we've got 100 there, 110 there. That must be 120. So you go across on whatever axis you're on until you find the value they've given you. So they gave us 24. You go up till you reach a point and then you go across until you reach your y value. So let's have a look at C. What is the internet use for the country which has an average numeracy score of 160? So this time we're going to do the opposite. We're going to go up first to 160, which would be here. We're going to go across 160 until you reach a point. Here we go. And then you go down until you get the next value, the x value. So for us, that would be 50. Now I'm just going to erase that just so I have a bit of room for the next couple of questions. Okay, question D. How many countries have internet use of less than 50? So for this one, I'm going to do it in red. Internet use of less than 50. So I would draw a line up at 50, and I would go, well, this is obviously more than 50 that way, so this must be less than 50 this way, and I would count up how many points have internet use of less than 50%. So we have 1, 2, 3, 4, 5, and 6. So we'd have 6 there. And if I was to do the next question, how many countries have a numeracy score greater than 100? So once again, I would do the same thing, but instead of being on the x-axis with 50, we're going to be on the y-axis with 100. So I'm going to go across at 100. This would be less than 100 because we're going down. So this would be higher than 100 or greater than 100, which is what the question asked. And so I'm going to once again count up how many countries have a numeracy score greater than 100. We have 1, 2, 3, 4, 5, and 6. So I'm going to put 6 as my answer for question E. So that's how you read a scatter plot. Determining a scale, you just see how much they go up by, how much each interval or how much each line goes up by, even the small intervals that don't have a value associated to them. When you're having a look at questions like B, you go across to the value that you know. So we know we're on the x-axis because it's internet use. We go across to the value we know, 24, and you'd use dotted lines going up and then dotted lines across once you've reached a point. And the same for the y-axis in question C. You go up to 160 and then across down to 50. And then if you're determining how many points, or in this case, how many countries have an internet use of less than 50%, you just mark off where 50% is and count however many countries are less than 50%. So there's not a question for this, but if there was, are we determining a relationship between the two? I would say yes, there is a relationship between the two. If I had drawn a line there, or like mirroring where the dots are going, so that line is a reflection of the dots, we can see that as internet use increases, the numeracy score also increases. So that's not the same for every single dot, but we can have a rough estimate that as we get more internet use, so as we're over in 80, 70, and 50, 60, we have a greater numeracy score than when we're over in the 10s and 20s internet use, which has a lower numeracy score. So those two variables, internet use and numeracy score, are an example of bivariate data, because as one increases, so does the other. Or as one decreases, so does the other. So they have a relationship. They go both being affected at the same rate.